Hi ladies, this is lesson 8.4 for geometry, and today we're going to look at areas of sections of a circle. So we've got a few key terms to define in this lesson, and we're going to look at some new formulas. We're going to derive some new formulas for calculating annuluses, sectors, and segments of circles. So not the entire circle like we did in the last lesson, but just pieces of the circle. So if you look at your vocab, you've got 3 new vocab terms. And on your note sheets, you've got diagrams for each of these. So we're going to define annulus as the region between 2 concentric circles. So you have to think back to some of your key terms from last semester. And this word concentric, that means 2 circles that share a center. Our next term here is sector, and a sector is the region between 2 radii and an arc of a circle. So here are 2 radii. 1, 2, those are our radii. And here is our arc. So a sector is the region, that shaded region between those 2 radii and the arc. And then lastly is segment of a circle, and that's the region between a chord and an arc of a circle. So here's your chord. It goes from one point inside a circle to another point to the outside of the circle. And then the arc is the arc that connects those 2 points of the chord. So your shaded region here is the segment of a circle. So our first section that we're going to get an equation for is the annulus, the area of the annulus. So if you think of this circle as, well, actually, you know what, before we do this, we're going to look back on your note sheet. There's this launch example. So in this example, take a minute and estimate the area of the shaded region. So we just defined this shaded region as a sector of the circle, and this is the radius, 4 centimeters. That means that this is also 4 centimeters. So estimate the area of the shaded region. Well, we know the area of a circle is pi r squared. And in this example, we know that r equals 4. Now, we're not looking for the area of the entire circle. We're only looking for the shaded region. So looking at this segment, at the sector, it looks like the shaded region is about a quarter of the circle. So we would say the area of this sector is a quarter of pi r squared, which means it's a quarter of pi times 16, because r squared is 16, which means the area is about 4 pi. So now let's look at the area of this annulus. So if you're estimating the area of this annulus, you want to think of this as 2 separate circles. So here's our first circle, our large circle, and then here's our smaller circle. Our large circle has a radius of r, and our small circle has a radius of lowercase r. So the area of our larger circle is pi r squared, pi capital R squared, And the area of our smaller circle is pi lowercase r squared. So if we take the area of our larger circle and subtract the area of our smaller circle, the area of our larger circle subtracted and subtract the area of our smaller circle, that's the area of our annulus. So that will leave us with just this area outside of the smaller circle. So our formula here is pi r squared minus pi r squared. Now let's think of the area of the sector. So if you look at this diagram, we're looking for this shaded region right here. But remember back to that launch example where we had just a quarter of the circle, and we said that this area was a quarter pi r squared. Well, this angle was 90 degrees, and 90 degrees is 90 degrees divided by 360 is the simplified version, or 1/4 is the simplified version of 90 degrees out of 360. Because this whole measure would be 360 degrees, but we're only taking 1/4 of that, or 90 degrees out of those 360. So we could write the equation for this sector in our launch example as the area equals 90 degrees over 360 times pi r squared. So we're going to do the same thing here in this example, where we look at the area of a sector. So we want to think of this as our angle, our interior angle A, divided by 360, times the area of our entire circle. And that's going to give us just that piece, where this is R and the angle is A. So our formula for area of a sector is our angle divided by 360 times the area of a circle. Right, now let's look at one example, and this is the area of a segment. So area of a segment, if you think of this whole region here, this would be a sector. We looked at this entire region, but we're not looking at the entire region, we're just looking at the region that connects a chord to the arc of a circle. So let's first think about the area of a sector, where this is our radius, and this is our interior angle. And again, we don't have this whole thing. We're subtracting that little triangle. So we're subtracting that part. And the area of our triangle is the base times the height. So we're going to subtract this little triangle, where here's the height and here's the base. And that's going to give us just the area of our segment. So remember that the formula for the area of the sector was A over 360 times pi r squared. The area for a triangle is 1/2 base times height. So taking the difference of those two will give us the area of our segment. So the area of our segment is A over 360 times pi r squared minus the area of our triangle, which is 1/2 base times height. So let's try a few of these examples now. So we're looking for the area of our sector. So we're first going to give our equation for area of a sector, and that's our interior angle divided by 360 times the area of our circle. So the area of our sector is 45 degrees divided by 360 times pi r, which is 20, squared. And if you simplify 45 over 360, you get 1/8 times pi, and 20 squared is 400. So to simplify this, the area is 50 pi, or the area is approximately equal to 157 centimeters squared. Right, let's look at a second example, and this is finding the area of the shaded segment. So we know that the base of this triangle here is 6 centimeters, that's the radius. And that means the height is also 6 centimeters. So we need to use the formula for area of a segment. And the area of a segment is our angle over 360 times pi r squared minus 1/2 base times height of the triangle. So here our area is 90 degrees over 360 times pi r squared, which is 6 squared, minus 1/2 6 times 6, base times our height. So to simplify this, we have the area is 1/4 times pi times 36 minus 1/2 times 36. And to simplify even further, 1/4 times 36 is 9. So 9 pi minus 1/2 times 36 is 18. So our area is equal to 9 pi minus 18, or our area is approximately equal to 10.26 centimeters squared. And let's look at one more example. Here is the shaded area. The shaded area is 14 pi centimeters squared, and the radius is 6 centimeters. Now we're looking for x. So we're looking for this interior angle. We know that the area of a sector is equal to the angle over 360 times pi r squared. So in this case, our area is equal to 14 pi, and that's equal to, we don't know what the interior angle is, but x over 360 times pi times r squared. Well, we have pi on both sides of the equation, so we can divide both sides by pi in order to eliminate that value. So we have 14 equals x over 360 times 36. So now in order to get rid of that 36 and the 360, we're going to multiply by the reciprocal. So we're going to multiply both sides by 360 over 36. And that'll eliminate the 36. And it'll eliminate the 360. And 360 over 36 is 10. So 14 times 10 is 140. So we come up with a value of 140 degrees is equal to x. So please jot down any questions you have, and we can address them next time I see you in class. Thank you.